Good morning, students. Today we are going to discuss about that module number 2, that is network theorems. Here we are going to discuss about that problems on Millman's theorems. So now we are going to discuss a problem on Millman's theorem. Find the current and voltage across the load terminals using Millman's theorem. So this is the problem what they given for us. So from this problem we have to find out the current which is flowing through this load terminal. Here load terminal is RL and RL value is equal here 2 ohms. So we have to calculate here RL value, the current flowing through RL value, that is 2 ohms, how much. So according to Millman's theorem states that in any two terminal linear bilateral network consists of voltage sources like V1, V2, V3 which are connected in parallel, and again it is connected in series with its internal resistance like 6 ohms, J of 6 ohms and minus J of 6 ohms, can be replaced by a simple Millman's equivalent circuit which consists of a single voltage source V which is connected in series with a single impedance Z across the load resistance of RL. So our aim is, according to Millman's theorem, our aim is to find out, according to the given problem, our aim is to find out that this V and this impedance across this load resistor, V and impedance. So what is the formula to find out V and what is the formula to find out Z? The formulas to find out V, how it is. So first of all here we have to write that what is V1, what is V2, what is V3. From the given problem, here V1 is 12 at an angle of 60 degree, V2 is 9 at an angle of 0 degree and V3 is 6 at an angle of 30 degree. And similarly, what is Z1 is equal 6 ohms, Z2 is equal 0 plus J6, Z3 is equal 0 minus J6. So now these values we have to substitute in the formula to find out that overall voltage V. To find out the overall voltage V, as we know the formula, that is V is equal to V1 into Y1 plus V2 into Y2 plus V3 into Y3 divided by Y1 plus Y2 plus Y3. Or Y means we can write as 1 by Z1, 1 by Z2, 1 by Z3, here also 1 by Z1, 1 by Z2, 1 by Z3. Then the formula can become as like this. So V1 into Y1, in the place of Y1 I am write it as 1 by Z1. V2 into Y2, I write it as 1 by Z2. V2 into Y3, Y3 I wrote as 1 by Z3, then become as V3 divided by Z3. Here Y1 plus Y2 plus Y3, Y1 plus Y2 plus Y3. Y1 I wrote as Z1 plus Y2 I wrote as 1 by Z2 plus Y3 I wrote as 1 by Z3. So in this formula I want to substitute all the data whatever here we have. So the data whatever here we have, that is V1, Z1, V2, Z2, V3, Z3. If I am going to substitute in the data here, V1 means here what we have, 12 at an angle of 60 degree. 12 at an angle of 60 degree whose value is there, it is in polar form value. Now I am converting that 12 at an angle of 60 degree rectangular form value is 6 plus J 10.92. As we know that in the given problem they given V2 is equal 9 at an angle of 0 degree. 9 at an angle of 0 degree is in polar form value whose equivalent rectangular form value is 9 plus J0. Next to V3. V3 value they given in the form of polar form value, that is 6 at an angle of 30 degree whose rectangular form value is 5.19 plus J3. Now all these rectangular form values has been used in this formula as to simplify it. If I am going to use all these rectangular form values as to simplify, in the place of V1 I am substituting the 6 plus J10. Z1 means I am placing that 6. Next, in the place of V2, I am substituting that 9 plus J0 and Z2 is nothing but J6. In the place of V3, I am substituting that it's a rectangular form value 5.196 plus J3 and Z3 means minus J6. And again in the formula, again I am substituting that if I am going to substitute that 1 by Z1, 1 by Z1 means 1 by 6, 1 by Z2 means 1 by J6, 1 by Z3 means 1 by minus J6. This is the way how to substitute that all the data. And if you simplify it, this one, if you are going to simplify it, previous step to current step, here if you see that very clearly, here 6 plus J10 divided by 6, here 9 plus J0 divided by J6, 5.196 plus J3 divided by minus J6. So if I want to perform that division operation, means the values are should be in polar form value. Now the values are in rectangular form value. So we have to convert all the values into polar form value. So if the values are A at an angle of B, that is in polar form, we can perform that multiplication operation and division operation. If the values are at rectangular form value, that is A plus JB, we can perform that addition and subtraction. So if the values are in polar form, we can perform the multiplication and division operation. If the values are in rectangular form, we can perform that addition and subtraction. Therefore, by simplifying this one, here we got the V. V is equal 3 plus J 6.588. V is equal 3 plus J 6.588 is the rectangular form value whose polar form value is 7.23 volts. Now I know that V is equal 7.23, but I want that similarly. What about that Z or Z equivalent? So according to Millman's theorem, what is the Z formula? The Millman's theorem, according to that Z formula is the equivalent Z in the Millman's theorem, that is 1 divided by 1 by Z is equal 1 divided by y1 plus y2 plus y3. Here y means again I have to write, that is Z equivalent. 1 divided by y1 means again I can write it as 1 by z1 plus 1 by z2 plus 1 by z3. I want to substitute in the place of z1 value, z2 value and z3 value. If I am going to substitute that Z equivalent value, while we are calculating that Z equivalent value, I want to substitute z1, z2, z3 values. If I am going to substitute that z1, z2, z3 values, then the simplified equation can become as this one, that is 1 by Z equivalent value. If Z equivalent value is equal to 1 by y1 plus y2 plus y3. y1 means I can write that 1 by z1 plus 1 by z2 plus 1 by z3. Here 1 by z1, this is Z equivalent. If I want 1 by Z equivalent means it becomes 1 by z1 plus 1 by z2 plus 1 by z3. So this is the simplified formula to find out that 1 by Z equivalent. 1 by Z equivalent, here it becomes 1 by 6 ohms after doing the simplification. Now I am going to use the two formulas like V and Z equivalent as to find out that the ultimate solution. V I want 7.23 and Z equivalent I got 6 ohms and the load resistor here it is 2 ohms. Then what is the current which is flowing in this circuit? The current flowing in this circuit, I is equal V divided by Z equivalent plus ZL. Here Z equivalent is 6 plus 2. Here 7.23 divided by 6 plus 2. 7.23 divided by 8. Then IL value can become as 0.9 amperes. So the ultimate answer here, IL is equal 0.9 amperes according to the given problem here. So According to the given problem, find the current and voltage across the load terminals. Now the current is equal 0.9 amperes. Current through 2 ohms is equal 0.9 amperes means the voltage across through 2 ohms is equal 0.9 into 2. It becomes 1.8 volts. Thank you.